guys, Travis Gillespie here. In the last video we worked on and looked at uh, identifying correlations or relationships between data. And looking at graphs helps you do that. Now we're going to kind of do the reverse. We're going to read some data and actually match scatter plots to the situation. Here's a good example. I'm just going to get some fresh space here and I'll throw it on the board for us. So it says choose the scatter plot that best requires the relationship between the number of years since a computer is purchased to the resale value. And from there, what it wants us to do is to actually explain it. So once I find the font here, it's kind of, oh, there we go. Move down and change the color of this guy. Cool. So now, actually extend it. So yeah, choose the scatter plot that best represents the relationship between the number of years since the computer is purchased and the resale value of the computer. Please explain. So sometimes we can actually look at a problem and say, hey, you know what? I have this problem here, and if the problem makes sense to me, I can look at scatter plots and say, you know, this scatter plot best represents this problem or scenario better than any other would. So looking at this another way, you buy a computer. You're going to hold on to it for a number of years, and then, of course, every year you can potentially resell it. And the question is, what happens to the price? Does it go up or does it go down? Well, we could just think about this in reality. Of course, you know, the price over time is going to go down because computers are manufactured or reproduced at such a high rate. In fact, by the time you purchase your computer and literally get it out to your car, it is obsolete. In fact, it's probably difficult to even find replacement parts for it because computers turn around at such a fast rate. However, you know, in reality, and thanks to the internet, it's not as difficult to find replacement parts as you would think. So we are given these two scatter plots, and we're going to take a look and see if one of them, it actually makes sense. So we already said, you know, over time, the price of the computer is going to go down. So I'm just going to leave it back at its original size. So the way to really think about this problem is to say, hey, the price of the computer is going to go down over time or as time goes on. So looking at these two charts here, we have resale value on the vertical axis and the years of since purchase on the horizontal axis. And let's see here, this first graph, it's saying, hey, that as time goes on, the price is actually dropping. And that seems to make sense with our problem. And this would show, hey, this is a negative correlation. If I drew a trend line, the arrow would go down. However, let's look at the other graph real quick. We still have resale value on the vertical axis and years since sold, but it's saying, hey, you know what? This, as time goes on, the price goes up. This is a positive correlation. And now the question, what it's really saying is, hey, capture the true situation. Which one of these best represents this problem about computers? So if you own computers longer and longer, you know the price goes down just by owning it longer. So just thinking and using common sense, you could say, hey, if this particular scatter plot were to make sense, in this case, well, the only one that can actually work out is the one on the left, the negative correlation here. This has got to be the scatter plot for this problem because as time goes on, the price, the value of that equipment or technology has dropped dramatically. Cool, neat stuff. So again, scatter plots are powerful, they're fun, they help you visualize and make sense of the information, or in this case, the relationships between data.